the periodic table and bonding. Well, so this question we are going to answer came in 2024 Science, Paper 2, which is Chemistry. And this is Godfrey Mumbi Academy. Make sure you do what? You subscribe if you are new to the channel. Alright, so I've always been saying, like, whenever they are bringing bonding, it is always coupled with the periodic table. Because of that, you need to understand the periodic table and also bonding. That's the only way you can answer the questions. So this is the question. The following symbols show nuclides of element X. So we have two nuclides of element what? X. So this nuclide, the first one, the number here at the bottom is 6. Then the number on top is 12. This one, the number at the bottom is 6. The number on top is 14. Like I always say, you need to know the difference. The number at the bottom is the number of protons, or the proton number, which we call the atomic number. The number on top is the number of neutrons, which we call, the total number of neutron and protons, which we call the mass number. So mass number is on top, atomic number is at the bottom. So the atomic number is 6 for both, but the mass numbers are different. This one 12, this one 14. Now let's answer the questions. What term is used to describe the two nuclides of element X? If you look at these two nuclides, they have the same what? Same proton number or same atomic number, but different what? Mass numbers. So elements with this feature is we call them isotopes. Okay, so these are isotopes. So for A1, we're going to say isotopes. So that's what we call these elements, as what? As isotopes. So we got the next question. When you look at the next question, it is saying define the term you have mentioned in A. Well, like I even explained, I said they have the same atomic numbers but different mass numbers. That's the definition. So you simply say these are atoms of the same element. Atoms of the same element having same atomic numbers but different mass numbers. Mass numbers. Oh, this is what we call isotopes. They have the same atomic numbers, 6, 6, but different mass numbers. This one 12, this 14. We got the next question. State the type of bonding that would be formed between sodium and element X. So, what type of bonding would be formed between sodium and this element X? Okay. So, sodium, we understand that is in group 1. It is a metal. So whenever you are writing chemistry, they will give you the periodic table. The periodic table, when you come to group 1, this is where you're going to find sodium. It has the atomic number 11, mass number 23. It is a metal. Now, it reacts with what? With X. It reacts with X. Look at the atomic number is 6. That's the one we use. So this element is on 6. This one has atomic number 6, which is carbon. So in short, they are telling you that the bonding that would be formed when sodium reacts with what? X, which is carbon. When sodium reacts with carbon. So you understand that sodium is a metal. Okay? Sodium is a metal while carbon is a non-metal. So this bonding is between a metal and a non-metal. That bonding is ionic bonding. Between a metal and a non-metal is ionic. So that is our B. you will say ionic bonding. If it was a non-metal and a non-metal, between non-metals, that is covalent bonding. If it is the one between metals or the one in metals, that is metallic bonding. Then the last question is saying, explain why most elements on the periodic table have mass numbers which are not whole numbers. If you look at the periodic table, the mass numbers, like the original, most of the periodic tables, the mass numbers are rounded off, but the actual numbers are not whole numbers. They have decimal points, almost all the elements. So the question is asking, why? Explain why most elements, the mass numbers are not whole numbers, they have decimal points. So you need to understand that this is simply because most of the elements on the periodic table exist as a mixture of isotopes. Okay, so this is the reason you write to say this is because most elements on the periodic table exist as a mixture. So the question has 2 marks. They exist as a mixture of isotopes. So this is the first point. So because of this, you understand that since they are isotopes, to find the mass number, the actual mass number, they find the average. That's the reason it gives them most of the times the decimal points. So therefore, you say therefore they find the average of their mass numbers, which gives the decimal points. So this is the reason most of the elements are not just elements, they are isotopes, like this one. You see that it is the same element, carbon, but this one is 12, this one is 14. So to find the relative mass number, you have to find the average. So you add this plus this, then you divide by the number of atoms that you have. If it's 2, you divide by 2. That's what that's what happens in most cases. And because of that, most of the elements on the periodic table have their mass numbers not whole numbers, okay, because they find the average. So this is what this question was all about. I hope you've gotten the concepts. Don't forget to subscribe.